In the course last week, we discussed how to compute double integrals and iterated integrals, and we did some estimation, and we kind of want to continue that theme this week and maybe expand our abilities with regards to being able to find the value of an iterated integral. Last week, you might remember we were over a particular region that was rectangular. Okay, and so this question, I want you to pause the video and just do it on your own, and then resume the video when you have this complete. Okay, well, if we did this, hopefully we had some time to do this. We should have got, so if we kind of simplify this first part in here, remember we kind of work one integral at a time, we end up with getting, let me erase that, 0 to 1, and then 1/2 minus x plus 1/2 x squared dx. And then if we integrate this and do some number crunching, we end up getting we get 1/6. All right, and then it said describe this region, and so if we think, well, certainly this is going to be, so this is a function z in the xy plane. So if I do this, something like that, okay, and we have x, we have y, we have z, okay, what it's going to be, and so if we were to rearrange this, it's really just saying x plus y plus z is equal to 1, and so it ends up being kind of a sheet when we look at it. But this restriction here of 0 and 1 restricts x to 0 and 1, so that's here, and then the other one for y is saying it's restricting along this bottom line here. So really we're looking at kind of this tetrahedron here in the first in the first octant. Okay, so that's kind of what it describes geometrically. Okay, and so now we're just going to continue along with that theme, and we want to find the volume under this particular plane, and above the region in the first quadrant, bounded by that. So now our story shifts just a little bit. So if we were to look in the xy plane only, so we're bounded by this, so that that is a line, or that is to say, okay, if we were to rearrange that, be x plus y is 1, and when we graph that, we end up getting this kind of region from 1 to 1 here, and then so we're looking at all this space in here as our region that we're integrating on. Okay, and then now if we put it in 3 dimensions, okay, here's that kind of region we're looking at, 1 and 1, and so we're still restricted to this region, and so we're looking now though at the volume under this particular function, which is a plane. X plus y plus z is equal to 3, and so maybe this isn't to scale by any means, but we have something like this where we might have a line here, and we have something up here, and oops, I drew that incorrectly. Let's try it kind of like this, and these would connect and then come down, something like that, and then there'd be a line here, and so something like this would, and then we want to find the area under, and area under kind of this top part of the plane that is within our region here. Okay, so we want to be able to do that, and so I guess in the past week we focused on regions that were rectangular. Now here you can very clearly see that our region is not rectangular. So how do we integrate over domains that are not rectangular? That's kind of going to be our focus for the day today, and so we'll pick up with some ideas in the next video.